Okay, start. Yeah, recording.
Okay. Okay. So this now the layout what you are seeing here. Okay.
I
So
can see.
are you aware about this? Not you cannot see the screen. Okay. Let me share it.
Yeah. Yeah, it's coming.
Okay. So now here the layout what you are seeing is called as the address space. Okay,
Okay.
address space region layout. Okay.
Okay.
So what is the importance of this? Yeah, are you aware about this representation? What I'm showing now?
No, I have heard about the CSA, LPA,
Hmm.
but um, not this screen.
Okay. So as a system programmer, okay, before you start your system programming, okay, this is the like your skeleton of your ZOS operating system. Okay, so any operating system you take in ZOS. Okay, so when you start the address spaces or when you start doing the IPL. Okay, so your address spaces whatever are coming up. Okay, each and every address space will be internally having this layout.
Okay.
Okay, so like suppose now I'm logging into TSO with my ID as IBM user. Okay, so IBM user will be considered as one of the address space. Okay, so that IBM user address space will be having a similar layout what you are seeing now here internally. Okay, so this is not your physical existence. This is just a logical representation of your address spaces.
Okay.
Okay, so in this now when you are doing IPL and when you are reading your load XX member, then you went into your IASYS member. Okay, so when you go into IASYS member, okay, so your IASYS member will be updating all these um, members which are mentioned here in the common area. Okay, so there is a common, private, and common in this address space. Okay, so this common area will be used by all the systems. Okay, so the most important area in your address space is this common area. Okay, so whenever your operating system is booting up, so it will be allocating most of the palm lib members under this common area. Okay, so this common area is again divided into two parts. One is your below the line and one is your below the bar.
Okay.
Okay, so when it is crossing the line, we call it as extended common and extended private.
Okay.
Okay, extended common and extended private. So below the line it is your common and private areas. Okay, so the area which is common here you can find nucleus, SQA, PLPA, FLPA, MLPA, and CSA. Okay, common storage area. Okay, so these are your like core of your operating system. Okay, so using your IEA SYS, we will be allocating all these spaces.
Okay.
Okay, so when you open your load XX member, in your load XX member, you are seeing nucleus and IEA NUC01. These are the two parameters or the palm lip members inside your load XX, okay, which will allocate the nucleus to this part here.
Okay.
Okay, so this SQA stands for your system queue area. This is the allocation of the memory size. Okay, so we will go into these things now. Okay, so what is CSA? What is why we use this PLPA, FLPA, MLPA, CSA, SQA, and nucleus. So if someone asks you what are the essential core this one IASYS members which we use, which the system uses during IPL is, if you explain these three members, that is sufficient. Okay, so now you have to like overall when you say address space, when you say okay, I am checking the address space. Okay, someone if someone asks you about the address space, okay, this is the overall layout which should be there in your mind.
Okay.
Okay,
Okay.
and you must be already knowing IFBR 14 utility, right?
Yeah. Yeah.
What that utility does? What is the use of that utility?
It's a dummy utility to create empty data set or delete data set. Or
Correct. So, so you write down one IFBR 14 utility, okay, and in that, I want you to execute that utility using this memory regions, okay. So
okay.
you have to see what is the output of the JCL when it is crossing your 16 MB. What is the output of the JCL when it is crossing your 2G?
Okay.
Okay, so what is the parameter you will be using for it?
Region.
A region parameter, yes. So you have to allocate your region parameter in your this one. So in this case, which part you will be giving the region parameter?
On in the JCL.
No, in the JCL only you will give, but in the JCL which part you will be giving? Like I want to see when I submit IFBR 14. Okay, I want to check the region parameter which is crossing 16 MB and which is below 16 MB. When it is below 16 MB, what it is doing, when it is above 16 MB, what it is doing. Similarly, I want to check when it is crossing 2 uh, GB what it is doing, and when it is below 2 GB what it is doing.
Okay.
Okay, so like in which like where you will specify the region parameter.
In that step.
You have to allocate in the step. So you will design a JCL, okay, with 4 steps. Okay. In the first step, you will be not allocating any region parameter. Okay. In the second step, you will allocate a region parameter which is equal to 16 MB. Okay. Third step, you will allocate a region parameter
to
which
2G.
is 2 GB. Okay. Fourth step, you will allocate a region parameter which is crossing your 2 GB. Okay, and you will see what is the append code it is giving.
Okay.
Okay, so this is a practical on this one. Okay, so how to remember this address layout is, okay, how do you remember this address layout is, you have to remember under common you have nucleus SQA, okay, PLPA, FLPA, MLPA, and CSA.
Okay.
Okay, so when it is going above the line, it is again extended. So extended SQA, extended nucleus, extended PLPA, FLPA, MLPA, extended CSA. Then
Okay.
it is extended user region, extended system region.
Okay.
Okay. So now at today you will be just like remembering under common what is there, under extended what is there. Okay. Then we will discuss this layout in detail later. Okay. So overall you should know when you say address space, you should know this layout should come to your mind. Like, okay, address space means internally, this is the logical representation of your address space.
Okay.
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 So now in IASYS, we will try to go through this, some of the members.
Okay.
Okay. Now you tell me from step one. Okay. I want you to select a load XX member. Then I want you to select the IASYS and IASYS member. Okay. So now you have opened your this TSO session. Now what is the path where you will execute the command?
In the SDSF, ST ulog.
Okay. So we will go to STSF,
Yeah.
ST. Then you will give
Ulog.
ulog. Then you will give HF11. Okay. It will take you to the center of the
Okay.
this ulog. Okay.
Okay.
HF11. Now here, what is the first command you are executing?
/d IPL info.
Okay. First one is your /d IPL info. First command.
Yes.
Okay.
Okay.
/d
IPL
IPL
info.
info. Okay. So you have given /d IPL info. What is the version of the ZOS here?
ZOS 011000.
This is your ZOS version.
Yeah.
Okay. First thing. Now from here you got your load XX number.
Yeah.
Okay. Now which is the sysres volume and which is the IODF volume here?
IODF device 0A82 volume JARES1. That is IODF 0A8.
This is your IODF volume. Which is your sysres volume?
This volume is JARES1.
Sysres volume is your JA
RES1. Okay.
JARES1. Okay. So sometimes they will not display this unit for device unit for your volume JARES1. So that
Oh,
time what is the command you will be giving? I want to check now. You assume that you don't have this device
okay.
details. Okay. You have only the sysres volume. So I want to find out what is my device for the sysres volume JAR. So
Oh,
second command you will be giving.
mm, I don't know that one.
Okay. So the next command is /d. Okay. User comma volume
Right.
equal to
J.
JRES 1. Okay.
Okay. Okay.
Okay. So this is the command you have to use.
Okay.
Okay. So they will ask you like first they will if they will tell you display IPL info, then they will ask you what is your sysres volume, then they will ask you what is your IODF volume. Okay, then they will tell you okay, this is my sysres volume, I want to know what is the device
Okay.
you need
Yeah.
for this. So you will be using the command display u comma volume equal to.
Yeah.
Okay, now
Okay.
I want to know what is my IODF volume. What is the command you will give?
IODF volume we can find from the IPL info or IPL
Okay,
config.
display IPL info. Hmm. Which is my IODF, sorry, IODF, okay, IODF device details they are given. Okay,
Yeah.
so I want to know what is my IODF dataset.
Yeah. That is slash T IPL
IO,
uh,
uh,
IODF iOS config.
iOS config slash d iOS comma config.
Yeah.
Okay, so now I'm giving slash d iOS comma config. Okay,
Mm.
so from here now you
IODF
got
data.
correct. So you got your now you got three details. One is your load XX member.
Yeah. And IODF data set.
You got your load XX member. You got your IODF data set.
Yeah. And we got the volume, device volume and the systress volume
You got the device volume, IODF device volume,
and the
and your
systress.
sysres volume. Okay, sysres volume. Got it. Okay, you got all these details. Now, with these details, we will enter into your. There is one more. Okay. So, okay. Hmm, okay, that we'll see later. So, with these details, now we will enter into your load XX member. Okay.
Okay.
So, display IPL info if you give. So, your load XX is your load 00, and your load 00 is present on this
Sys1.ipl.
sys1.ipl pump. So, always it will be present in the sys1.ipl pump. Okay, so if it is not present in your sys1.ipl pump, then where the system will search it?
In the Palm Lib libraries.
In the
In
palmlib library. So it is sys1.palmlib. Okay, sys1.palmlib on which volume?
on 0A82
0A82. That is which volume? 0A82
IODF volume.
IODF volume. So if it is not found on IODF volume, then where it will search?
It will search on the systress volume
Which is your sysres volume?
0A80.
0A80.
Yeah.
Okay, so this is your search order for your load X6.
Yeah.
Okay, so you got your load X6 search order. Okay,
Yes.
so now next is we will enter into your load X6 here, load 00. Okay,
Okay.
sys1 dot
IPL Palm.
this is your load X6. Okay, so From your iOS config, you got your IODF dataset. So you can now here always you have to give this calls. Okay. So once you give the calls, you should make sure that whenever you are coding through your parameters here, you should not forget what is the column from where the individual parameters are starting. Best example is here you are giving your volume. Okay. So
Okay.
volume should always start from your 55 column.
Yes. Okay.
Okay, like this. Okay. So in your load XX member, the first data set your system is reading is your IODF data set.
Yeah.
Okay. Why it is reading IODF data set?
That is the input output device information.
Ah, yes. So for your system to boot up, you require your even you require your sub channels and your all your hardware configuration. So for that, you are first giving your IODF dataset details.
Okay.
Okay. So what will be your IODF dataset naming convention here?
sys1.iodf99.
sys1.iodf99. Okay. IODF 99. Okay. So if you have not mentioned here 99, if you have mentioned equal to, then it will take your existing the current existing IODF dataset, whatever is there, the recently created, it will take that one.
Okay. Yeah.
Okay.
Okay.
So in some of the Palmlib members, here they will be given equal to, and they will give sys1.
Okay.
Okay. So at that time, it will take the existing data set.
Okay.
Okay. The second parameter is your syscat. Okay. Syscat is your master catalog. So your data set name will start from here.
Yes.
Okay. And this is your volume serial for your master catalog.
Okay.
Okay. So now most important parameter is your syspam. Okay. So when you say syspam, it is
I
your
I S.
IEA SYS. Okay. So our system by default it was having zero
Zero.
one as the IEA SYS 01 as the member. Okay. So we added one more member called as
DB
IEA SYS DB. So why we added this IEA SYS DB?
for finding the subsystem DB
Co-
CNCS.
Correct. So when this system was loading, okay, when this system was loading, when it was completed, we were not able to find any subsystems. That is your CICS and DB2 were not coming up. So what we did, we tried to find a IEA SYS member in which SSN was DB. Okay, in which they had allocated SSN equal to DB. So this IEF SSN DB member was having your subsystems. So we added it here.
Yeah. Yes.
Okay. So now, which is the second Palmlib member which your system is reading? Which is the second Palmlib member which your system is reading during IPL?
IEA SYS01.
Correct. It is IEA SYS.
Yeah.
Which is the default IEA SYS member?
Default is IEA SYS 00.
IEA SYS 00.
Yeah.
Okay.
Okay.
IEA SYS 00. So now here I have mentioned IEA SYS 01. Okay. So if whatever parameters are given under IASYS01. Okay. After reading all the parameters inside IASYS01, your system by default searches the parameter given under your IEASYS00.
Okay.
Okay. By
Okay.
default, it will read IEA SYS 00.
Okay.
Okay, so if it does not find any of the essential parameters in 01, then it will start reading 00.
Okay.
Okay, so when you specify here 01 and db, okay, so it if any of the parameters are left in 01 and db, then it will search it in IASYS 00.
Yeah. Okay.
Okay, so last class we discussed up to here. Then next is your IEA SYM 00.
Yeah.
Okay, so this IEA SYM 00, again it is like by default it is 00. You can mention 01, and if you want some more parameters you can give it. Okay, so what this parameter is doing is it is substituting your symbolic
Yeah.
parameters to the system. Why we require symbolic? Because your system parameters will be in huge number, and it requires to randomly allocate in any of the member. We want those parameters to be randomly allocated. So what we do, we give a logical name, that is a proxy name to the actual parameters. We store those parameters in one location, and we keep on using the your uh, proxy name or your logical name wherever we require. So now here when you open your load xx member, okay, if you come across IASYM00, it means that you are using a symbolic parameter IASYM00. Now if you want to see what and all is written, what and all are the substitution under this IASYM00, then what, how you will check it inside the system?
Display symbols.
Display symbols. Okay, so if you go into your STSF again, you will go into ST, you will go into ulog. Okay,
Yeah.
you will give HF11. Okay, then you will give slash D SYMBOLS. Okay, so now see, these are the subs for these all parameters.
Substituted.
Your logical names are this one.
Yeah.
Okay, so instead of using Z110S, I'll be using and Unix VR. Okay,
Okay.
so you can add some more your symbolic parameters inside your IA SYM, and if you give display symbols, it will display here in the down.
Okay.
Okay,
Yes.
now the next important is NUC LST00. Okay, so NUC LST00 and this nucleus one.
Yeah.
Okay, so this is your explicitly you are including this, and this is by default it is given by the system internally. So
Okay.
both you have to mention. Okay,
Okay.
so what it does is it will allocate the nucleus member here in like this. In this area, it will allocate your nucleus inside the address space.
Okay.
Okay, so when your system address space is built, right, so the nucleus part will be included inside this.
Okay.
Okay, so where this will be there, NUC LST00.
You will be in the system. Palmlip. 6-1 Palmlip.
So now here one more thing you have to remember is apart from this master catalog, okay, the members what are written here, okay, that is your IASYS, IASYM, your NUCLST, and your nucleus. Okay, these palm leaf members where the system has to search. where it will search, because for your load xx member, you have given as an input as a load xx and you have given iodf. Now next, whatever parameters you are mentioning, giving to the system as an input, those parameters will be searched under this palm leaf concatenation.
Yes.
Okay, so IEA SYM will be searched here in this three. IEA SYS will be searched in this three. Your NUC LST will be searched in this three, except this one, nucleus equal
Okay.
to 1. This will be searched in sys1 dot nucleus.
Okay.
Okay, and we mention the volume serial for this palm concatenation because your performance should increase. It should immediately pick this all
Palm
your
lips.
palm
Palm.
lips.
Yeah.
Okay, so
Okay.
now if you want to find your NUCLST, you will be trying to search here because in this system it is saved in this parameter library. So you go to,
It has only one include member, right? Nucleus.
sorry, this one will be stored in your this one will be stored inside here. It is NUCLST 00.
Okay.
So this is internally including a nucleus, this one, and it in your address space, and it will be allocated in this part nucleus.
Okay. And there is extended nucleus also.
Extended nucleus here. This how this address space is working is okay. Some of the programs will start executing above 16 MB.
Oh,
Okay, that time these layout will be used. Okay, if the program is below 16 MB, then this layout will be used.
okay. Okay.
Okay, now the next member is your NUC nucleus 1. Okay, so this where it will be stored is,
Nucleus. This one dot. Yeah, we found it in the nucleus library.
oh sorry, it will be there in sys1 dot nucleus.
Yeah.
So last time we checked, right? So it will
Yes.
be there in sys1 dot.
Nucleus.
So it is IEA, not IEF. So IEA NUC.
Oh, okay.
Okay. So this is again your fourth nucleus thing. Okay. This only thing we have to remember is where it is, in which library. Okay. So these are the two inputs we'll be giving. Then after that, the syspam. Okay. So now we will enter into your, and this is your sysplex name.
Okay.
Okay. So the next one is your syspam. So we are using here 0, 1 and dB. So now, so this will be in this data set.
Yes.
Okay, so here, from here your system will start reading all the essential members. So here in this, now again if you go to this address layout, okay, so we saw nucleus now. Okay, so if you try to find of SQA, see,
Yeah.
so we have a member called as SQA system queue area. Okay, so this is like you are allocating the address space again, and here you will give the range of the address space, size of approximately 640K. So if you want to see more details about this, then SQA. You will go to your MVS initialization and tuning reference. This document you have to always keep with you. Okay, so this is like your Bible
Okay,
for
this is the
programmers.
yeah, if I Google it out, I will get it, right?
Ha, you will get it.
Oh, okay.
Here it is the SQA system queue area. Okay, SQA parameter in IEA SYS. Okay, so if you go into here, okay, so this parameter specifies the size of your virtual system queue area. Okay, and extended SQA. So this is the queue. So like suppose for your input and output operations, you will be having the queues, right? So it is allocating your virtual system queue. Okay. So the subparameters A specifies the size of your SQA located below your 16 MB. So I am saying, as I am explaining you here, it is below your 16 MB.
Okay.
Okay. So located below your 16 MB. The subparameter B specifies the size of your extended SQA located above your 16 MB. So you can give SQA equal to A comma when your address space the programs are trying to use both these regions, that is your 16 MB and 2 GB. Okay, so if some of the programs are using below 16 MB and above 16 MB, then you give SQA equal to A comma B.
Okay. But now we saw only one value, right?
Right.
260. Yeah.
Hmm. We saw only one.
Okay.
So
So
that
that
260 you have to convert it into MB and see where it will come.
oh okay.
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 So this is theoretical things, but overall, like one or two sentences you have to remember about this, why it is used. Okay, so how to allocate it is SQA equal to A comma B.
Okay.
Okay, so even most of the programmers will be like they'll be knowing what it is doing exactly, but in depth, if you want to uh, like study, then they will also refer this manual. Okay, tuning and reference manual.
Okay.
Okay, so after that, the next member what is in your address spaces. Okay, uh, PLPA, FLPA, and MLPA. Okay, so here you can see find for PLPA. So here it is there. See, so LPA, MLPA. Okay, so when you say LPA equal to 0, 1, it is selecting LPA LST 0, 1. Okay,
Okay.
LPA LST 0, 1. So this is LPA is your link back area. Okay,
Okay.
so what this LPA LST member will be having is it will be having all your retrent executable programs, okay, which are used by your system during the IPL, like your system related modules. Okay, like when your system is booting during the IPL, what are the essential load modules which are required for your system to work properly? Those all modules we will keep in LPA, MLPA, and FLPA.
Okay.
Okay, so most of the time it will be a concatenation of your sys1 data sets, sys1 dot star. Okay, so why this is used, why LPA LST is used is when your system is booting up. Okay, when your system is booting up for your ZOS operating system, there will be inbuilt load modules which your operating system should use for its functionality. Okay, all those modules will be stored in your sys1.lpa lib. Okay, by
Okay.
default, okay, by default it is sys1.lpa lib, lpa lib. Okay, now what happens is during my IPL, okay, during my IPL, I will not mention this LPA equal to 0, 1.
Okay.
I will not mention it. Okay,
Okay.
then system by default takes all the modules which are stored under sys1.lpa lib.
Okay.
Okay, so it takes all your executables from your sys1.lpa
Yeah.
lib. Now we will try to see. Okay, sys1.lpa lib. So this module, you see where it is stored. It is stored on your sysres volume. This is your sysres volume. In general also, it will be stored on your sysres volume. All your sys1 dot star data sets which your system is using during booting will be stored on your sysres volume.
Okay.
Okay, so now here you can find sys1.lpa lib. If you won't give your lpa lst00, then all these modules which are there under sys1.lpa lib will be read
Okay.
by the system by default.
Okay.
Okay,
Okay.
then if your lpa lst00 member, if the system is unable to open it, okay, if it is unable to open LPA LST member, then the system will prompt you with the information message of IEA 712I. Okay, IEA 712I.
Okay.
Okay, this code you have to remember, IEA 712I. It
Okay.
is unable to find your LPA LST member.
Oh,
Okay, so now we'll try to go inside your LPA LST. What is the LPA LST member here is 01. Okay, so we'll try to go into your LPA LST 01, where it will be stored
oh, the palm. Okay.
in the palm lib.
Okay.
Find for LPA LST 01. Okay, it is here LPA LST 01. Okay, see here LPA LST 01. Okay, ADCD, okay, ADCD Z110S dot LPA okay, so your extension should be LPA
Okay.
okay, so why they are including this ADCD ZOS dot LPA why they are including this module sys1 dot LPA is there, then your um, see most of the things like there are some of the like user defined LPA libs also, but in most of the production system you'll be not having this user dot LPA lib. Okay,
Okay.
like this ADCD dot LPA lib. Okay, this will be starting with most of the time will be starting with your sys1 dot
Okay.
LPA sys1 dot LPA lib like sys1 dot this ACR LPA. Okay, so why they are including these modules here? Why they are including it here?
So, since the user is
So they want this whenever your ADCD system is coming up. Okay,
okay.
this practice system is coming up. They want all these modules to be included for your ZOS operating system
Okay.
to function properly.
Yeah.
Okay, so this is the main functionality of LPA LST. Like it will include all your operating ZOS operating system executables.
Okay.
So now if you okay, one more thing what we can check it here is you remove this. My sysres volume is JARES.
One. Yeah.
So see here, now you will be finding your LPA LIB modules. See,
Yeah.
so they are specifically keeping on your sysres volume so that These are your ZOS uh, modules which are required during your ZOS install.
Oh,
Okay, so we were discussing about quick start, cold start, and warm start, right? So what they do if they want to check only your ZOS, whether your ZOS, all the modules and your ZOS operating system is loaded properly, and only if essential address spaces are active and running, then they will do your quick start. Okay, so in your quick start, they will just test whether all these modules in your LPA, LPA, LST, FLPA, LST, specifically these regions, okay, whatever is mentioned in these regions, whether the modules in these regions are functional or not. That is the use of your quick start.
okay.
Okay, so we will discuss on LPA, LST. I have around 9:15. I had to join one more session, so
Okay.
we'll stop it here. Okay, we will discuss LPA, LST, and master JCL. Okay, so now the next here will be your uh, LPA, LST, FLPA, MLPA, then your master JCL. Okay,
Okay.
so if possible by you today, we will again continue at 10 p.m.
Okay.
and we will complete this IESYS members.
Okay. 10 p.m., right? Okay.
Yeah, okay.
Okay.
So we'll close it here today.
Okay. Okay. Sure.
Yeah, yeah.
Thank you.
Thank you,
Yeah.
thank you, thank you. Bye.
So much. Bye.